Okay, so to solve the system using these word problems, you've got the steps up there. You need to identify the variables, write the equations, solve for the variables. The three different ways we've talked about: substitution, elimination, and then doing the matrix, which is what we talked about last class. Okay, along with the Gaussian elimination. Okay, so going to that example 1. It says Ticket Hub sells 2 types of concert tickets. The price for bench seats are $75. Lawn tickets are $40. Organizers said they sold 350 tickets for $19,250 in revenue. Which of the following systems would fit that situation? On a lot of problems, especially with multiple choice, and the choices is the actual system, it will go ahead and identify the variables for you. Okay, because they have to have the variables within the system. So looking at that information, can somebody tell me what one of the equations would be? Garrett, Carter.
C. Oh, one of the.
Just, yeah, we're going to write the equations, then we'll do that.
75B plus 40L equals. Oh no, what do we mean? 19,000.
Yes. So 75B plus 40L equals 19,250. Okay, so I've used that information, and that information. What would my other equation be? Someone other than Garrett, Carter, Cole, Connor, sorry. What's the other equation? B plus L equals 350. Right. If you ever hear me, and a lot of times you will have these kind of equations. If you ever hear me refer to a equation as the number of, this is what I'm talking about. The number of this plus the number of this is going to give me the total number of whatever the problem's talking about. Okay, seats at a concert. The one above, a lot of times you'll hear me refer to this one as the value equation, which is just taking the number of, and you're just putting the value of each variable that it's talking about in front of it. Alright, the bench seats are worth 45, so it's 45B. The lawn, 75. The lawn is 40, so 40L. The price, what they made off of all these, the value of all these was $19,250. Okay, so a lot of times you'll have those kind of equations, number of and value, for lack of better terms. And then you can obviously see that D is the system that we just wrote. Okay. All right, let's go to example number 2. Ashlyn, will you read that one for me?
Food truck's revenue for selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day?
Okay. So, looking at that, Devontae, what would be first, we need to identify the variables. So we'll use S for salads, D for drinks. Okay. Devontae, what would be one of my equations?
S plus D equals 209.
Awesome. Number of salads plus number of drinks equals 209 total items sold, which they only had the 2 different kinds. Alright. Max, what would the other equation be?
S650 plus.
Okay. So 6.5S plus.
6.5S plus 2.0 or 2
Mm-hmm.
D equals 836.50.
Okay. Now, last time we talked about whenever you had dollar amounts, You could do it without the decimals, but you could do this one. It would look like this. 650S plus 200D equals 83,650. But those numbers are getting so large that I think the benefit of getting rid of the decimals, that's going to make it too difficult with the numbers getting that big. I would just rather deal with the decimals in this problem. Alright, so Max, since you gave me that last one, do you want to solve this one by substitution or elimination?
I would do elimination.
Okay. Which variable would you eliminate? D.
Times the top of my -2.
Awesome. I'm going to multiply the top equation by -2. Alright. Doing this one by elimination, well, I'll make that point at the end. So I've got -2s minus 2d equals -418. So now the d's eliminate, and I've got 4.5s equals 418.5, I believe. So let me double check that. Is it right? Okay. Then somebody tell me what 418.5 divided by 4.5 is. How many salads is that going to give me? $93. Do I need to solve for the number of drinks?
No,
Why not?
because it didn't ask for it.
Doesn't ask for it. Just ask for the number of salads. Okay. So the point I was going to make was elimination is good on this problem for the reason that they only ask for one thing. Okay, so if I know that they're asking for salads, I can eliminate the d variables, and now I'm just solving for the number of salads. Okay, it's a lot easier to kind of to isolate the s variable by doing elimination. So going to number 3, it says I've got 12 coins and quarters and dimes. Total's $1.95. How many of each? Okay, so you can identify your variables again. I think I talked about that last time. If you just want to do it that way, that's fine. Okay, so after that, Bo, what would one of the equations be on this one? Thank you, Bo. Your voice sounds a lot different than it did last time I talked to you.
Oh, I didn't hear you say something. Apologies.
It's all right. So there's. So what would the other equation be?
25Q plus 10 equals 190.
Awesome. So on this one, I would get rid of the decimals, which is what Bo did. Okay. So since on the previous one, since we did elimination up there, I'm going to do substitution here. Okay, so I'm going to pick, again, find the variables that's easier to solve for. Neither one of those have coefficients in front of them, so I'm going to solve for one of those. Okay, so if I solve for D, then I'm going to subtract Q. And I'm going to put 12 minus Q in for D right there. So I end up with 25Q plus 10, 12 minus Q equals 195. Distribute the 10. Okay. Combine like terms to get 15Q. I would subtract 120 over to the right, so it would equal to 75. Which tells me 5 quarters, which would give me how many dimes if I have 12 total coins? Somebody's about to whisper it. I can hear him. If I have 12 coins and 5 are quarters and the rest are dimes, how many dimes do I have? 7. Thank you. Star Amphitheater charges $75 for each seat in Section A, $55 for Section B, $30 for the lawn. There are 3 times as many seats in Section B as in Section A. The revenue for selling all 2,300 seats is $87,000. How many are in each section? So how many different kind of seats are there? 3. So how many variables are we going to have? How many equations should we expect to have to make? 3. So let's identify the variables first. So we will do x as Section A, y as Section B, z as the lawn seats. Okay. Colton, what would one of my equations be?
You could say A plus B. Or
Keep going. A plus B.
could I use that? Or
I'm following you. A plus B.
alright, A plus B equals 2,300.
Okay. Not just Section A and Section B, but also the what? The lawn seats. Okay. So x plus y plus z, because that's what we're using those variables for Section A and Section B, and then the z for the lawn seats equals 2,300. Okay, that is the number of. So if I had somebody to go walk through the whole amphitheater and just count the seats, 1, 2, 3, okay, it's going to add up to 2,300. So I've used really just that information. Cambridge, what would another equation be for this problem?
75x plus 55y plus 30c equals 87,000.
Awesome. Okay, I've used all that information. Next, I've got to get an equation from this sentence right here. Do what? Okay. And everybody always, it's either 3y equals x or 3x equals y. Everybody always just puts a 3 on one of them. And anytime you're comparing two of the variables, you're going to have one on one side of the equal sign, the other on the other side, and whatever it's talking about. 3 times one amount is equal to the other. Okay? Whenever you're doing this, think about which section is going to have more seats. Okay? If Section B has 3 times as many as in Section A, which section is going to have more seats? B or A? B. So the variable that represents that needs to be by itself. And comparing that to the number in Section A, it's 3 times however many is in Section A. So if there's 5 seats in Section A, there's 15 in Section B. Okay? And if you've been to many amphitheaters, you might know that, usually Section A is right there by the nice stage. Section B is a lot bigger. So the kind of the VIP or the ones closest to the stage, you're probably going to have less of. That's using your concert knowledge there. Great. Great. Yeah. Absolutely. Okay. So we're going to do this, solving this by matrix. Okay. Now, one thing that we didn't run into last time that you need to know is every equation that you put into a matrix has to be in standard form. Raise your hand if you have no idea what I mean by standard form. Okay, I think some of you are lying to me as well. That didn't raise your hand. So, standard form If it is two variables, it's this. But since we have three variables, it's this. All you really need to know about the standard form is that all the variables are on one side of the equal sign.
So the first two are
Okay.
the same form.
So these two are fine because x, y, and z are all on the same side. This has variables on either side, so we need to change it. So I can subtract 3x to the left. There's nothing left on the right. And let me write it like this actually. I'm going to put it in order. So negative 3x plus y equals 0. And so these are the three equations that I'm going to put into the matrix. Okay. Now if you remember last time, I highly recommended that you label the columns. That way you can go through. So I'm going to go down by each column. So my coefficients for x is 1, 75, negative 3. Coefficients for y is 1, 55, 1. For z is 1, 30. If I don't have a z, what do I put? 0. After that, I've got my answer matrix, which is 2300, 87,000, and 0. If I'm putting this in my calculator, what am I missing? The minus 1, the exponent of negative 1. Make sure you have that up there, okay? So on this one, you should have gotten that there were 150 seats in Section A, 450 seats in Section B, 1,700 seats in the line. Okay?